In this video, we'll have a look at how we can use Spacio to design, analyze, and create a compliant project proposal. We'll be working with proper context, editing and assessing terrain conditions, combining generative and freeform design, running compliance checks, analyzing sun, daylight, and view conditions, and finally exporting a finished model to IFC. Everything you see in this video is currently available through signing up for a Spacio account at spacio.ai. Let's get started by creating a new project in the project dashboard. We'll give it a name and quickly make note of the sketches badge, which allows us to have unlimited sketches for each project. The first thing we're tasked with is choosing a project location. Here we have selected Oslo, and then we point to a large development area just south of the city center. This has been the grounds for many architectural competitions for the past few years, and is the perfect setting for our project today. Once we've set the location, we're prompted with the option to import context from Mapbox. By selecting Yes and starting the project, we immediately get the local terrain, buildings, and street network. A total of 1 square kilometer is imported. Multiple architects have been working on different parts of this development, and we have a competition brief that we also want to include as context. Since Spacio operates very well with Rhino, we can easily combine the real context with the competition brief using the Rhino import. We now have the proper context and a good foundation for starting our project. The terrain conditions in a project location will always affect the architecture one way or another. Elevation differences determine how much mass needs to be removed or added. Hills can affect daylight conditions, and terrain sloping can impact stormwater runoff. Therefore, having the right tools to analyze and interact with the terrain is vital for creating a realistic building model. Spacio allows for various ways to visualize and interact with terrain, such as terrain sloping, direction, elevation, satellite images, and elements from Google Maps. This provides an intuitive understanding of the terrain conditions while designing our project. Let's start off by selecting the area where we'll be creating our buildings and remove some of the context that came from the Rhino model. Using the cross-section tool, we can assess the elevation. Right now it's completely flat, but let's shape the terrain a little bit. First, we start by defining an area using polylines. Once the area is defined, it can be raised or lowered as needed. When we manipulate terrain, we will immediately see how much mass needs to be added or removed from the project area. With the help of different terrain viewing modes, we can clearly visualize different terrain parameters, for example sloping or elevation. Going back to the cross-section tool, we can see that the area is now slightly raised from before, which makes sense here to counter flooding. Keeping track of building code compliance is tedious for most architects. There's just so many different parameters and regulations to keep in mind. That's why many resort to verifying compliance after the model has been finalized. The problem with this approach is that issues can be uncovered very late, when it's a lot harder to change the model. This can in turn lead to project delays and expensive rework. Luckily, with the help of Spacio's integrated compliance system, we'll be notified of non-compliance immediately and can mitigate issues on the go. That way we can design with confidence and trust that the finished model is building code compliant, dramatically reducing the risk of delays and reworks. Let's have a look at the compliance system in practice. We'll get started by drawing the plot boundaries on the area we worked with previously. We define the setback distance and give the plot a name, which is useful when working with different plots in the same project. Now let's use some constraints for the compliance system. These constraints become our safety net when designing buildings. For the purpose of this example, we'll define them manually, but Spacio will soon support national building codes and have an import option for any additional regulations. For example, let's define that buildings cannot exceed 32 meters, and that 20% of the total gross area should be designated as outdoor areas. Then we select the plot and generate an initial proposal by clicking the buildings in the tool menu. Now let's go in manually and adjust the number of stories on some of the buildings. Immediately, we see warnings in Spacio's compliance system for both fire regulations and building height. If we continue to increase the number of stories, we also get warnings on the outdoor areas. Fortunately, we can easily correct the issues in a few seconds. When we reduce the number of stories, we immediately get a pass for both maximum building height and minimum outdoor area. We still have a non-compliance on fire distance, stemming from the buildings that sit too close together. But by moving the buildings further apart, we correct the issue and get a pass. Problem solved. Generative design helps architects through quickly producing a range of different design options as a starting point for further work. It's great for exploring the possibilities of a plot by letting the architect combine their own expertise with algorithms for a faster and hopefully better outcome. Let's delve deeper into the generative design aspect of Spacio. We're back at the plot again and want to try some more design options. Our design from before has been saved as a sketch. Let's select the plot and quickly generate a first proposal. Then, we're going to adjust some of the parameters in order to generate options that match our target outcome. Let's adjust the minimum parcel area so that we get a huge courtyard in the middle. Secondly, let's adjust the openness and allow some space between the buildings. However, we decide that we rather want to use the big courtyard for buildings instead, and adjust the parcel size back down again. Lastly, since there could be some wind issues in this area, we want to reduce the openness again. Clicking New Design repeatedly, we get a bunch of suggestions. These can be saved in a list for us to review later, where we can pick our favorite options and compare them. But for now, we're just going to generate different options until we spot one that we like to use as our starting point. Now that we have settled an option, let's add some more stories. Simply clicking the top of the building and dragging the cursor upwards will generate more stories. It's also possible to adjust the story height, let's say for a taller first floor, or perhaps a more exclusive penthouse. If you want to do some more specific editing, we can for instance cut buildings in half, and then adjust the separate parts. Facades can be split and extruded, walls can be angled and tapered, and entire buildings rotated and moved around. But for now, we're just going to change the roof type and aperture settings for some of the buildings. Let's select these 3 buildings. Head to the control panel and change them to green roofs. On this corner towards the sea, we want to change the window dimensions. We select the building and use the aperture settings and adjust the placement, height, and width. Finally, we have a sketch that we're happy with and can move ahead. When working in Spacio, we can decide what type of building we're working with by categorizing them. This allows us to create mixed-use projects where we can set different attributes for each category and bulk update changes for it without affecting other parts of the building mass. It's also relevant for the compliance system, where specific parts of a building can have different rules from neighboring parts based on its intended purpose. Lastly, categorizing allows us to clearly visualize with colors which blocks, buildings, stories, and spaces are designated for which purpose, and generates useful metrics in our dashboard. Via the control panel on the right-hand side, we head to Display Modes and select the Category option. By default, the buildings are categorized as residential, but we can select any part of the building and recategorize them. Let's select the bottom story of this building and categorize it as commercial. Perhaps it's meant to house a neighborhood cafe. Then on the corner building towards the sea, let's set the first story as commercial and the rest as offices. We could imagine this being a prime location for businesses that want a view of the sea and an easily accessible restaurant. Via the statistics panel on the left-hand side, we can always keep track of the total GFA and the GFA per category. If we want to keep specific stats visible all the time, then we can simply pin them to the top of the screen. The numbers will update automatically as we keep refining our design. Even in early project stages, it's incredibly helpful to keep track of building information in order to create realistic models, rather than just working with generic volumes. Buildings designed in Spacio are always created with proper internal structure and building information. They consist of foundations, stories, cores, slabs, walls, roofs, apertures, units, spaces, and so on. Any volume created in Spacio is by default split into units, and we can set the target parameters to optimize the unit mix. When we make changes to the volumes, such as flipping the cores, for example, the algorithm will respond and rearrange the internal structure automatically. With the help of various display modes, we can represent the building in different contexts. If we want to present an early sketch to a client, then perhaps we don't want to show it with apertures, roofs, or other details, since it can cause confusion about the final product. Luckily, all we need to do is select a lower level of detail in the LOD menu. Having a firm grasp of building performance while we're designing is key to creating both compliant and performant buildings. A core part of Spacio's offering is the ability to run various analyses to assess sunlight, daylight, and view potential. Importantly, these analyses can run in real time while we're changing the design. We don't need to enter a separate analysis mode. That way we can instantly see how our design choices affect our building performance and can make better decisions. Let's start off by looking at sunlight hours on outdoor areas. Easy access to direct sunlight is proven to be beneficial for health and is a building code requirement in some countries. So, taking this into account when designing, make sure that we can include this quality as part of our proposal. Using the control panel, we can change parameters regarding the time of day and year and the threshold values. Let's set the date to May 1st, and let's look at the hours between noon and 8 in the evening. Then let's set our thresholds, to define that 50% of the plot should receive at least 3 hours of direct sunlight in that time frame. With these parameters, we can tell that only 32% of the plot will receive sufficient sunlight, meaning that the design does not comply with our target. But if we tell the analysis to include green roofs, which are areas that residents can stay in, the number increases to 35%, an improvement, but still not enough. When issues occur in the design, it's great to know exactly where the problem lies. So let's select different previews to highlight which areas receive sufficient sunlight and which fall below. As we can tell, the areas in red will be too dark. This gives us a great opportunity to tweak the design in order to bring those areas up to spec, perhaps by adjusting building heights or creating some openings. Via the same control panel, we can have a look at the sunlight potential on the facades. Direct sunlight is a sought-after quality, so apartments with good access to it can fetch higher prices. On the other hand, too much direct sunlight can lead to heat and blinding issues, which need to be mitigated with larger ventilation and window shading. Either way, having control of this in early stages means that we can make better decisions down the road. The sunlight potential is indicated by a heat map that makes it easy for us to spot problem areas. And we have the same parameter and preview settings as before, letting us analyze the potential under different conditions. Next, let's have a look at the facade's daylight potential. The heat map on the buildings and the graph in the stats panel indicates how much of the sky is visible from any point of the facade. Like before, we can use the preview buttons to only show results that are either good, pass, or are too dark. In this corner, for example, we can tell that this part of the building will never receive sufficient daylight. The facade's daylight potential has a direct correlation with the internal daylight potential of the rooms, so good access is important. A real-time analysis tool for internal daylight is arriving in Spacio soon. Lastly, let's assess the view potential from different points on the facade. The views analysis tells us how much of the facade has an obstructed view, and again lets us factor in this in our design from the very beginning. Good views is a very sought-after quality for most property buyers. The generic preview is based on a 180-degree horizontal view. However, we can create points of interest by placing out listeners. The heat map then indicates which parts of the facade will have a clear or obstructed view of the interest points. In our example, we've placed the listeners in the sea, as sea views are typically something that will increase the value of a property. As we can tell, 78% of the total facade has an obstructed view to our interest points, meaning that they can only be seen from about a fifth of the facade. Good interoperability, or the ability of different design and analysis tools to communicate with each other, is critical for creating an efficient workflow. Without it, we're stuck with doing tons of manual work and remodeling. Sadly, this is still the reality for most architects around the world. In Spacio, perfect interoperability is something we strive for. The platform already supports a slew of different import and export options. Some are automatic, and some require a few keystrokes. But importantly, all information should be retained, so you don't have to remodel stuff you've already done. Here we'll have a look at how we can export our model to the IFC file format, so that we can use this model in various BIM suites. Let's start off by clicking the Export button and selecting IFC. Via the menu that appears, we can decide which layers of the model we want to export. Like mentioned, buildings in Spacio are not just simple volumes, but consist of typical BIM elements. As such, we can retain all information in the export file. It can also include all context, such as the terrain, streets, and existing buildings. While not visible here, Spacio supports both metric and imperial units, both for designing and exporting. The time it takes to generate the export file depends on the size and complexity of the model, but typically takes a few seconds. Now that we've generated the IFC file, let's open it in a viewer to have a look. As we can tell, the model looks good, and is ready for further work in the later stages of our project. If you'd like to try out Spacio for yourself, then sign up for an account at spacio.ai. We'll provide all necessary training and support to get you started. If you're unsure if Spacio will fit your workflow, then feel free to book a call with us and we can help you determine if it's a right fit. You'll find all relevant links and contact information in the video description.